Suppose that on the geometric plane we have a line and a point F that is not on that line. We define a parabola as the set of all the points that are equidistant from the line L and from the point F. Let's illustrate this situation. So we have a point P. This point is on the parabola if the distance between point P and F is the same as the distance between the point P and the line L. Let's recall that the distance between a point and the line is the distance along the perpendicular to the line L. That perpendicular line passing through the point P will cross the line L at some point Q, and this distance, this length of this segment is the distance between the point P and the line L. And if the distance we denote by D, parabola is the set of all the points P such that this distance between P and Q is the same as the distance between P and F. This is the definition of a parabola. Now, point F is called the focus of the parabola, and the line L is called the directrix of that parabola. Now let's draw a line that is perpendicular to the line L and goes through the focus F. So let's draw the line right here. This line will cross the line L at some point, and let's call it O. And let's take the point that is halfway between F and O and call it V. Because V is halfway between F and O, and therefore the distance between the point V and F is the same as the distance between the point V and the line L, the point V is on the parabola. The point V is called the vertex of the parabola. Let's notice another property. If we draw the symmetric image of the point P across the line going through the F and V, you can easily justify looking at the congruent triangles that the distance between P1 and F is the same as the distance between P1 and L, because these are the same distances and on the other side. And therefore, parabola, the point P1 is going to be on a parabola. So the parabola is symmetric with respect to the line FV. So that we can say that the line FV going through the focus and the vertex is the line of symmetry for that parabola. The graph of the parabola will consist of two branches that start with the vertex and go in the direction of the focus. We'll discuss one more property of parabolas that will be very helpful when graphing them. Let's draw a line that is perpendicular to the line FV, to the axis of symmetry, going through the focus. This line is going to cross the parabola, and let's call those points on the parabola A and B. What can we say about the points A and B? Now let's look at the distances. Since those points are on the parabola, then, for example, distance between the point A and F is going to be the same as the distance between the point A and the line L. But the distance between A and the line L is the same as the distance between the point F or focus and the point O. So if the distance between the focus and the vertex we denote by A, the distance between A and F is going to be twice that much, because the distance from F to O is 2A. And so is the distance between the point B and F. It's also equal to A. This segment AB is called the latus rectum, from Latin, opening wide, and it determines how wide or how narrow a parabola is. So let's recall briefly all the properties of a parabola. Vertex is halfway between the focus and the directrix. The parabola is symmetric with respect to the line going through focus and the vertex. The parabola has two branches originating at the vertex, and they go in the direction of the focus. The line segment perpendicular to the axis of symmetry going through the focus forms the segment AB, which is called latus rectum, whose length is 4 times the length between the focus and the vertex.